The start of the manufacturing process at Valley Contax has changed recently, and with the onset of our focal points manufacturing system, our jobs are digitally sent into the lab now. And so what we have here is an operator that will come over and launch a job to get going, and it'll print out our job slip. So coming out of here is our work order, and we have our material, and everything is tray coded as for shipping. We have a very wide array of colors, and again, all the colors that are manufactured by our vendors are carried by us. And we pull out of our vast array of manufacturing parts, our blanks, our buttons. We update our queues so that we know exactly when a job was ordered, what the rush quantity is, and the most important jobs as far as speed going to the top. This is our base curve 3-axis machine. The first manufacturing step on a contact lens is cutting the concave part, the base curve. All the things that used to be done by hand are now done by our CNC lathe. So the part is set in the collet, scanned on the barcode, and all of the components that make up this lens for the corneal surface of this patient are encased in that barcode. The lens goes through its motion with a precision switch, which tells the lathe exactly where that part is, and then it begins its cutting process. Our lathes utilize 2 main diamonds. Most of our cutting processes are done on the roughing diamond, which will cut out all but 1/10 of a millimeter of that contact lens, and a finish diamond, which is reserved for taking off that last 1/10 of a millimeter to give the lens a very smooth, virtually polish-free surface. So as the finished cut is done, you may see a very, very fine stream of swarf, which is the blow off of the plastic, and that's you can barely see it because it's only 1/10 of a millimeter wide and cutting off a real fine trace. This is our bladder polisher base curve polishing tool, which polishes all surfaces, all curves for us, simultaneously. This is as opposed to having the big wall of individual catered convex tools to polish these concaves. This is a pressure-filled rubber balloon, so to speak. Moisture is huge in here. Heat will always hurt contact lenses and destroy wettability, so we're always constantly keeping lenses moist and polished. This is an aluminum oxide polish that we use. It's the similar polish to mirrors and glass application. That is a 14-second cycle on the base curve. And then this is a post-polished, pre-measured base curve. What we try to do after the lens is lathe cut, we try to keep that pristine surface as clean and smooth as possible. This Neats analyzer measures the mass of the blank, the thickness, and it also measures the radius, and it gives us an optical score. So what you're going to see here is the base curve that's measured, 6.196 by 6.19. The button thickness, now the button thickness is from the apex of the base curve all the way to the back side of the button, and the contrast is a 55. So now the base curve and the button thicknesses, which is our pertinent information, is attached on that job, and it's ready to move on to the next step. Once a base curve is cut, polished, and verified as to correct, and the numbers are attached to the file, this automatic base curve or mounting machine is designed to mount this lens on an arbor. These are just a Delrin firm plastic arbor that is a safe product to use in case a diamond hits it or in case anything happens. They're mounted with an upper collet. There's 2 collets here and here, an upper collet and a lower collet, as well as a wax dispensing system. This is a very important little piece of fabric here which keeps the amount of wax consistent on every blank. It's very important to have a proper cushion between the lens and the arbor. If you have too much, then your wax does not harden, and you can have air bubbles and optical problems that way. If you have too little, then your arbor becomes in direct contact with your base curve, and you can destroy the lens and have too much pressure on the surface of the blank. So for a safety measure, another double cycle start, this shim is going to come out through here, take a measurement of where that is. Our wax is dispensed via this hot plate, and the noise you hear right now is just simply an air pressure coming out and emitting a cooling flow to harden that wax. This machine is tremendous in eliminating unnecessary prism, unnecessary runout, and creating a very stable blocking system for us, very consistent and very stable. So we're going to cut the OS lens here and scan that in. And the computer recognizes the job file, recognizes the fact that it's a Toric. We'll get that motion going. A roughing diamond is going to take out most of this material. The baseline for a Toric is where you've got a high amount of astigmatism and the cornea needs a completely different radii on different parts of the cornea. This machine is equipped with several features. One is a milling tool that actually marks our flat meridian. That mill is a key for us to manufacture this. It uses that as a reference point to be able to achieve a very accurate bi-toric. And now, basically on the front surface, this camera is going to turn on. It's going to rotate. It's going to take a picture of it. It's going to rotate it again. And then as soon as it notices that contrast twice, it zeroes out the meridian so it knows exactly where the flat meridian is. So as with all of our jobs, we scan in that front surface. It tells us we're about to cut a front. We hit our cycle start buttons. And what's going to happen then is a camera is going to turn on right here on our Contax checker, and it's going to find that orientation mark, and it's going to instantly mark that to 0. So it's going to come in, pick it up once, pick it up twice. As soon as it recognizes it twice, looks like it wants to do it again. There, it likes it. Okay, so then it's going to come in through, it's going to use its precision switch, and now what it's done is it's orientated that lens to the exact 0 marker, and so the precision of putting the proper optics on the proper meridian is very high with this machine. After the lens is front cut and the power is laid into the lens, the front surface laid lines are then polished off with our front polish machine using our microfiber silk and again our aluminum oxide polish. We use a synthetic microcloth fiber, something we've gone to over the last few years, and it's a very fine weave synthetic silk that we use to polish both sides of our lenses, and it works real nice. This stage of this lens would be what would be called an uncut lens. This is a lens that's been, of course, cut on both sides, polished on the front, is about ready to be deblocked via an ultrasonic machine, and comes off virtually clean. The cleaning process is quite simple. It is just put in a mild, just above room temperature bath with a mild detergent in there for about 15 seconds, and the lens is completely wax-free. What we have now is an uncut lens. We have a lens that has a pristine surface on both sides. If the lens is manufactured completely properly, we've got the proper power, base curve, and diameter. And where the lens goes right now is to what's called our automatic edging system. Here is where the edges go from a squared off, thin yet square edge to a rounded, comfortable, ready-to-wear edge. We've got a small, mild vacuum that does not distort the surface of the lens. It doesn't take much to pull that too hard. This arm is dropped in here, and this basic sponge is something we use all in our finished side, and we use it to change powers to round edges, and it basically rotates against the grain of the sponge and creating a soft edge. After the lenses are popped off of here, they're ready for our quality control finish department. These two stations here are identical, and they're both taking lenses off the auto edger. The first step here is to put this lens in the aperture of the lensometer and verify that our power is right. From here, the operator comes over, checks it out on all aspects, runs the edge, the full scope of the edge to look for chips, thick edge, thin edge, and making sure that it's a quality, round, smooth edge. The diameter is then verified using the same diameter measurement gauge that we've been using for a long time here. And we use it called a V-groove gauge and measure the diameter and make sure it checks out within ANSI tolerances. And then the center thickness is measured. We run within a 0.02 millimeter center thickness tolerances, and this one is within 0.01. This lens is then prepared for plasma treatment with a tong that exposes the surface of that lens to our oxygen-based plasma machine. So this is our plasma treatment machine. We are doing currently about 80% of our lenses through this, and when we talk about plasma treatment, we don't really talk about coating, or we don't really talk about anything that can wear off. What it really is, as much as anything, is just a high pressure scrub for the lens to clean off any surfactants or waxes or polishes or residue that may be in there. The lenses are inserted into this chamber. Okay, so now what's happening is the vacuum pump is in effect sucking out all of the air in this chamber and turning it into a completely oxygen-free environment. 99.6% pure oxygen is piped in. Now when that chamber has now hit purple, that means that the oxygen level in the chamber has reached its potential, agitates that oxygen at a very high rate, excites it over the surface of that lens, and that act is called plasma treatment. Then it'll ease out and release the pressure to the chamber, and the process is complete. Here is where the lenses are then shipped in solution back to our patients. We use the hydration method to keep the properties of the plasma treatment intact. This is done in a sterile environment, and when they're shipped hydrated, they are even more ready for an easy dispense and a comfortable in the chair patient.